Reading a blog from Engineering at Meta, Capacity Efficiency at Meta. How Unified AI Agents Optimize Performance at Hyperscale. We're sharing insights into Meta's capacity efficiency program, where we've built an AI agent platform that helps automate finding and fixing performance issues through our infrastructure. By leveraging encoded domain expertise across a unified standardized tool interface, these agents help save power and free up engineers' time away from addressing performance issues to innovating on new products. We've built a unified agent platform that encodes the domain expertise of senior efficiency engineers into reusable, composable skills. These agents now automate both fixing and finding the performance issues, recovering hundreds of megawatts of power and compressing hours of manual regression investigation into minutes, enabling the program to scale megawatts delivery across growing number of product areas without proportionally scaling the headcount. On defense, FP Detect, Meta's in-house regression detection tool, catches thousands of regressions weekly. Faster automated resolution means fewer megawatts wasted compounding across the fleet. On offense, AI assisted opportunity resolution is expanding for more product areas every half, handling a growing volume of wins that engineers would never get to manually. Together, this is how Meta's capacity efficiency program keeps growing megawatts delivery without proportionally growing the team. The end goal is a self sustaining efficiency engine where AI handles the long tail. Let's take a brief look at what FP Detect is. They have linked a research paper for the same. FP Detect catching tiny performance regressions at hyperscale through in production monitoring. This paper presents Meta's FP Detect system, which advances the state of the art in performance regression detection by catching regression in as small as 0.005% in noisy production environments. FP Detect monitors around 800,000 time series, covering various types of metrics, example throughput, latency, CPU, and memory usage, to detect regressions caused by code or configuration changes in hundreds of services running in millions of servers. FP Detect introduces advanced techniques to capture stack traces fleet-wide, measure fine-grained subroutine level performance differences, filter out deceptive false positive regressions, deduplicate correlated regressions, and analyze root causes. Beyond these individual techniques, the key strength of FP Detect over prior work is its battle tested robustness, proved by 7 years of production usage, each year catching regressions that would have wasted millions of servers if left undetected. Getting back to the blog. So, from what looks like, they are striking a direct comparison between FP Detect, which is something that already exists in their ecosystem, and now AI assisted um, opportunity resolution, which they have built. Here's how it works and where we're headed. Efficiency at hyperscale requires both offense, proactively finding optimizations, and defense, catching and mitigating regressions that make it to production. AI can accelerate both. Okay. We've built a unified platform where standardized tool interfaces combine with encoded domain expertise to automate investigation on both sides. These AI systems are now the infrastructure of the capacity efficiency program, which has recovered hundreds of megawatts of power, enough to power hundreds and of thousands of American homes for a year. Yep, that is right. Most times we um, don't understand how much of power consumption is involved in, running all these systems that we built. But all the systems that are running at hyperscale, in organizations like Meta and other big tech organizations, the power consumption is um, way beyond our comprehension, even as software engineers. The final point that I've mentioned is automating diagnosis can compress about 10 hours of manual investigation to about 30 minutes, where AI agents fully automate the path from efficiency opportunities to ready to review pull request. Introducing the capacity efficiency program. When the code you ship serves more than 3 billion people, even a zero point 0.1 performance regression can translate to significant additional power consumption. In Meta's capacity efficiency organization, we see efficiency as a two-sided effort. Number one, offense, searching for opportunities, proactive code changes to make our existing systems more efficient and deploying them. Second, defense, monitoring resource usage in production to detect regressions, root cause them to a pull request, and deploy mitigations. These systems worked well and have played an important role in Meta's efficiency efforts for years. However, actually resolving the issues they surface introduces a new bottleneck: human engineering time. This human engineering time can be spent on any of the following activities: querying profiling data to find opportunities to optimize hot functions, reviewing an efficiency opportunities description, documentation, past examples to understand the best approach to implement an optimization, checking recent code and configuration deployment that could have caused a step change in resource usage, looking through the recent discussions about launches that might have related to a regression. Many engineers at Meta use our efficiency tools to work on these platform problems every day. But no matter how high quality the tooling is, engineers have limited time to address performance issues when innovating on new products is our top priority. That holds true more for, smaller startups and smaller organizations, but I mean, this is holding true even for big tech organizations like Meta. So I mean, we can only begin to imagine how um, this looks like for relatively smaller organizations. We started asking, what if AI could handle investigation and resolution? Offense and defense share the same structure. The breakthrough was realizing that both problems share the same structure. You know, number one, gather the context from diverse data systems. Number two, apply domain expertise to interpret that context. Number three, produce an actionable path to resolution. This meant we didn't need two separate AI systems. We needed one platform that could serve both. We built it on two layers. Number one, MCP tools. These are standardized interfaces for LLMs to invoke code. Each tool does one thing: query profiling data, fetch experimental results, retrieve configuration history, search code, or extract documentation. Number two, skills. These encode domain expertise about performance efficiency. A skill can tell an LLM which tools to use and how to interpret the results. It captures reasoning patterns that experienced engineers develop over years, such as consult the top GraphQL endpoints for endpoint latency regressions, or look for recent schema changes if the affected function handles serialization. Together, the tools and skills promote a generalized language model into something that can apply the domain expertise typically held by senior engineers. The same tools can power both offense and defense, only the skills differ. Defense. Catching regressions before they compound. FP Detect is Meta's in house regression detection tool that can catch performance regressions as small as 0.005% in noisy production environments. It analyzes time series data like when FP Detect finds a regression, we immediately attempt to root cause it to a code or configuration change. This is a vital step to understand what happened. It's done primarily with traditional techniques such as correlating regression functions with recent pull requests. After a root cause is determined, engineers are typically notified and expected to take action, such as optimizing the recent code change. We've added an additional feature to make this faster: AI Regression Solver. Our AI Regression Solver is a newest, most promising component of FP Detect, which produces a pull request to fix forward the regression automatically. Traditionally, the root causes, the pull requests that created more performance regressions, were either rolled back, slowing engineering velocity, or ignored, increasing infrastructure resource use unnecessarily. Now, our in house coding agent is activated to do the following: gather context with tools, find the systems of regression, such as functions that regressed, look up the root cause, a pull request of the regression, including the exact files and the lines changed, apply domain expertise with skills, use regression mitigation knowledge for the particular code base, language, or regression type. For example, regressions from logging can be mitigated by increased sampling. Create a resolution, produce a new pull request, and send it to the original root cause author for review. Offense. Turning opportunities into shipped code. On the offensive side, efficiency opportunities are proposed conceptual code changes that are believed to improve performance of existing code. We built a system where engineers can view an opportunity and request an AI generated pull request that implements it. What used to require hours of investigation now takes minutes to review and deploy. The pipeline mirrors the defensive AI regression solver. Gather context with tools. The AI agent looks up: number one, the opportunity metadata; number two, the documentation explaining the optimization pattern; number three, examples showing how similar opportunities were resolved; number four, the specific files and functions involved; number five, validation criteria for confirming the fix works. Apply domain expertise with skills. Use expert engineers' knowledge on a specific type of efficiency opportunity and code it into a skill, for example, memoizing a given function to reduce CPU usage. Creating resolution. Produce a candidate fix with guardrails, verify syntax and style, confirm it addresses the right issue. Surface the generated code in the engineer's editor, ready to apply with one click. Importantly, we use the same tools as defense, profiling data, documentation, code search. What differs is the skills. One platform, compounding returns. Our unified architecture with shared tools and data sources has been a clean abstraction. Each existing and new agent has an easy way to gather context about the performance with the interfaces we've made without the need to reinvent the wheel. This post focused on our first use cases, performance regressions, and opportunities. Within a year, the same foundation powered additional applications, conversational assistants for efficiency questions, capacity planning agents, personalized opportunity recommendations, guided investigation workflows, and AI assisted validation. Each new capability requires few to no new data integration since they can just compose existing tools with new skills. Impact. The result of the capacity efficiency program are significant. We have recovered hundreds of megawatts of power. The AI systems for both offense and defense contribute to supporting this effort. But the deeper change is in how offense and defense reinforce each other. Engineers who spend mornings in defense triage now review AI generated analysis in minutes. Engineers using our efficiency tools can now get AI assisted code instead of starting from scratch. The daunting question of where do I even start has been replaced by reviewing and deploying high impact fixes.